This explanation is about cubic and cube root transformations. Your transformation formulas are here. They are very similar to the equations we used for quadratic. The change is this 3 here instead of a 2. And the equations that we used for square root, the difference here is there's a 3 as the index. The first graphs that we'll talk about are cubic. It's helpful to have a calculator for this so that you can make yourself a table and be sure you are graphing the right equation. So here I've already typed in this equation into the calculator, and make sure to raise your group to the third power, and then we can look at the graph. You can get your inflection point, which we'll put in the middle of the table, from the HK. Oops. From your transformation formula, or you can look here in the middle of the curve and confirm for yourself there that the inflection point where it changes from opening up to opening down is at 3, 2. So when we look at the table to collect, when we look at the calculator table to collect the other points that we'll use for graphing, we need to look around 3, 2. What's the middle of here? So I can use points that are near to 3, 2. So I'll use 2, 3 and 1, 10. I'll also use 4, 1 and 5, negative 6. I'm going to pause this. I'll go ahead and plot my points. You do the same. And I'll catch up with you when my graph is drawn. Struggle is real. I was going to pause this. We're just going to roll with it. Wait a minute. So frustrated right now. Oh, okay. Now that my graph is drawn, I will fill in the transformations. You can find these in your calculator. Well, you can look at the parent graph in your calculator. How about that? I'll just do x to the third power. And then the transformations that you'll describe are the description of what you'd need to do to this red graph, the original graph, to make it look like the blue one. They seem to be the same shape. However, the blue one is decreasing. That happens because A is negative. So your graph reflects over the x-axis. We also moved the inflection point. It was originally at 0, 0, and now it's at 3, 2. So my graph has to shift right 3. The h value shifts left and right. So because h is not 0, I shift right 3, and my k value moves my graph shift up 2. This graph from left to right is decreasing. You can check your table here and see that these y values are getting smaller. And domain and range for all cubic graphs is negative infinity to infinity. The next graph I have is x cubed minus 1. So I will draw this graph. Compared to the original, it shifted down 1. There's only one transformation. It's this right here. No, sir. My inflection point is at 0, 1. You can see that it moves up and down, but not left or right. And I don't change shape or direction. It's because A is 1. So there's no change to shape or direction. And H is 1. Nope, H is 0. So there's no change. There's no movement left or right. But K is negative 1. So that shifts my graph down 1. When I look at the table in the calculator, I'm looking at the blue numbers. The red ones are the original graph. So I need to make a table from these blue numbers, and I will start at 0. Oh, whoops, 0, negative 1, silly. Here. Yes, we shifted down. And so I will add these other points and make myself a table. I'm going to pause just for a moment, and you can fill in your table and draw your graph. All right, my table is completed. My graph is drawn. I did transformations first. You can see that this graph is increasing. The y values, as the x values increase, the y values increase also. And we'll fill in domain and range. Okay. Next. Okay, this one looks like we got all kinds of stuff going on. Several transformations. I'll put this in my calculator, make myself a table. You do the same. Practice for yourself. And I'll pause, you pause, and we'll get the table filled in and the graph drawn.